So we are a very small installation, about 1,500 civilian Army employees and about 100 active duty uniformed soldiers that are there. We do science and technology on everything that the soldier carries, wears, eats, sleeps in, sleeps under, jumps out of airplanes with. So it's a pretty fascinating job, and our customer, you know, the U.S. Soldier is an easy customer to get behind, and it's an easy customer to to want to give it your all. So I am the deputy director for the food program, and even though we're located on an Army installation, we have the great mission to do all the research and development for food that feeds our entire warfighting force, to include the Marine Corps, Navy, and the Air Force, along with the Army. So I'll talk a little bit about some of the science and technology efforts that we're currently working on. I'll only have time to just really scratch the surface, so if you're interested in any of these things, we can talk offline, and I'd be happy to go into more detail. But we really, in the context of prevention of food waste, I think I want to bin it into two separate topics. We have some technologies that will reduce the amount of food waste, but then there's also some technologies that help to mitigate and reuse the waste that is produced. It was mentioned yesterday that, you know, as great as our efforts will be, there will always be some sort of food waste, so what do we do with that and kind of put it to use afterwards? So I'll start with some of the technology, some of the pretty cool emerging technologies and that might help to reduce the amount of waste that's produced. One of the very big efforts that we're involved in is extending the shelf life of food products. It probably shouldn't be a surprise that, you know, when we're talking about warfighters that are operating in a very remote, a very austere location, like we've seen for the last 15 years in Afghanistan and Iraq, our soldiers are carrying everything they have is on their back. You know, one stat is a dismounted infantry soldier carries a little over 100 pounds. I don't know the conversion to kilos, but it's pretty heavy. And food is a part of that weight. And if they have to make a trade-off between ammunition or food, I can tell you which choice I would make. I would take more bullets than beans, I guess is the phrase. But so it really behooves us to make food very lightweight, very low volume, and last a very long time. And we have traditionally extended the shelf life of products through the thermal sterilization process. Retort might be a familiar term to you. But that's a little over 200-year-old technology developed by Napoleon for Napoleon's army. It wasn't by Napoleon, but it was actually a French candy maker that developed this thermal sterilization process. And basically it helps food to last a very long time. So we've made some improvements to that process, but we're really looking ahead. So one of the ways we're doing this is through a process called sonic compression, and it actually uses sound waves, passing it through a medium into a product. So a bar like this typically uses some sort of sugar or binder or filler ingredient to, you know, combine the nuts with the berries and the fruit and things like that. So we're looking at products that have a very clean label but are very lightweight and low volume. So we're doing the same thing, except these sound waves actually spot weld the ingredients together so that you don't have this filler, really a non-nutritive filler that adds weight, adds volume, and creates kind of a muddled label. So it's a pretty neat technology. We're also working with NASA on their 5-year mission to Mars. They're also looking at very low weight, low volume products, and so this technology came out of that project. And I think that could have a very big impact for us. It also creates an extended shelf life, very extended shelf life product, which would help to in that area of food waste. Another very promising technology is this ethylene control device that we've looked at. It came out of a Navy project. So if you're familiar with naval operations, these guys go out to sea for a very long time. Typically, they get resupplied by tender ships that are going out maybe every month, every 3 weeks, if you're lucky. So their supply of fresh fruits and vegetables is very limited, maybe a week to 2 weeks at a time, and their yield gets lower and lower as the weeks go on, and you're peeling back, pieces of lettuce that have gone bad. So what we've done is we've developed this. It's called an ethylene control device. It's a small box that's mounted into their chill space, their refrigerated space, and basically it uses UV light to break down ozone into water vapor and carbon dioxide. And we've seen an extension of about 7 to 14 days on lettuce, about 21 days on tomatoes, and that there's a whole other stats on peppers and cucumbers and things like that. So we've essentially extended the shelf life of these fruits and vegetables, which helps to save a lot of money. But in an application of prevention of food waste, something like this technology inserted into the supply chain commercially, or into a developing country that is trying to get access to fresh fruits and vegetables, but because of their location, that supply chain is very long. This could have tremendous impact and not only help to get nutritious products to groups like this, but also it helps to prevent basically loss of product. So when you start with a nice head of romaine lettuce that's very full, and the end product is this a cold head of lettuce, and you've lost 45 or 50% of the product, that could pay tremendous dividends. All right, I'll move into some of the waste mitigation issues now, or the ways we use, the ways we try to treat the waste that is produced. So I don't know if you've seen pictures of some of these battlefields over the last 15 years in Afghanistan. If you have, probably somewhere in the background you've seen a big cloud of smoke. Not proud to say this, but we take everything with us when we go into a new area of operation, and a lot of times most of the waste is burned. They dig a big hole, they throw all the trash in there, and to include food waste and packaging waste, and they just light it on, they incinerate it. And there's been some studies, minimal studies, on the byproducts, what's in the smoke coming off of that, and what it does to people downstream of that. But either way, it's not a good thing. So we've started to look at this idea of clean incineration, taking the food waste along with the packaging and whatever other waste they're producing, and clean incinerating it, installing scrubbers, to scrub the effluent, and basically all you're left with is an ash. One of the other pretty neat things is called a waste to energy converter. So this whole idea of reusing this organic material to create energy. So basically it's a big container. I think it's an 8 foot by 8 foot by 20 foot container. On one end it has a hopper. You put it in, it goes through a whole gasification process, breaks down the organic material, extracts the energy. So just through that process, it creates enough energy to power itself, and also you can recharge batteries, which is very important military application. These guys are using a lot of gear that runs on batteries, so they're recharging batteries and powering different pieces of equipment. So again, tremendous commercial application. It can be scalable, so it could be put it into any type of dining facility, a university dining facility, or a hospital, or anything like that for their waste. But it helps to, you're not just throwing it away and filling a landfill somewhere. You're getting rid of it cleanly. You're actually getting a benefit out of it, by way of the energy that's being created, and doing great things with the waste. So I think that's about all the time that I have, but there's more I could go into. So.
Thank you very much. Wow, fascinating.